Okay, hi. So in this session, we are finally going to put our rational functions onto a graph. So if you've been watching the other ones, you're gonna, this slide should look really familiar. We still want to find our key features first. That's the first part of graphing in. But then these final eight steps, 8 and 9, are going to be the ones where we put it on the graph. So we're going to find everything, we're going to plot this, then we're going to find some extra points. I'm going to give you some hints on how to find those extra points, and then you go ahead and graph them. So we did this example, just talking about the key features. When we're looking at graphs, it is important when you're graphing a rational to have an idea in your head of what a rational function should look like. So every time you have a vertical asymptote, it splits your graph into different parts. So this one has one vertical asymptote, so I have a part here and a part here too. This one has two vertical asymptotes, so I have three distinct parts. This one has two vertical asymptotes, so again, I have three distinct parts. This one has one, two distinct parts. On the edges, you're always going to have kind of this curvy feel. It almost looks like the corner of a very soft box. So on the far edges, you'll always have something that kind of looks like that. Sometimes, especially when you start looking at ones that have oblique or slant asymptotes, that curvy edge of the box might look a little bit steeper. It might look more like this. So do know sometimes you will see things like that. But every time you have a horizontal asymptote, or sorry, a vertical asymptote, it is going to split your graph into distinct parts. So use that information as you're graphing to make sure that your graph looks something like a rational function you've seen before. So this one we're going to start with. This one already has our information found for us. If you're not sure how I found this, go back and watch one of my videos that's just the first one on key features. It goes ahead and it does this entire problem out for you. So the first thing you want to do is go ahead and actually plot the things that you have found, your key features. So I have a y-intercept at 3/5. It's a little bit more than half. I'm really just going to kind of put in there. We're going to be estimating as best we can. Obviously, that dot can be placed exactly at 3/5. I have an x-intercept at -3/2, which is also the same thing as -1.5. And then we can put in our asymptotes. Your asymptotes are going to be dashed lines. And that's because they're actually imaginary. They don't really exist there. They exist, but they're not actually part of the graph. So we dash them in to use them as a guide. So I have one at -5, a vertical one at -5, x equals -5. So I'm going to go over on the x-axis to -5, and I'm going to draw a vertical line here. I'm going to try all of that again. Okay, so that's my vertical asymptote. I'm going to do the same thing for my horizontal asymptote, but it's going to be a horizontal line. So I'm going to go up to y equals 2 and draw a horizontal line over. So to y equals 2, draw over this horizontal line. Now, one of the things that we just said on the other page is that each time we have a vertical asymptote, it splits our graph. So for this one, I'm going to say I have two sections. I'm just going to call it section 1 and section 2. And that's because of this vertical asymptote. So I have some sort of graph going on over here. I'll have some sort of graph going on over here. Because I do have a horizontal asymptote, I know that I'm going to have some of those swoops. So my graph is going to most likely, it's going to look like something like this. And I know that the bottom one's down here because I already have points there. I'm not sure if this one's up here. It could actually be down here. I don't know where it's going to be, so I need to find some more points to figure this out. I know my graph was going to look something like that. So in order to figure out exactly what it looks like, you need to choose coordinates in section 1 and some more coordinates in section 2. In order to find the coordinates, we choose x values. I always try and choose an x value that's really close to my asymptote. So in section 1, the closest x value to my asymptote, it's a whole number, is -6. I'm also just going to go ahead and choose -8 and -10 while we're here so that I can quickly find those. I'm going to say that's section 1. Actually, I already have some points in section 2, but it can't hurt to find more. I want to find one that's close to my asymptote. So in section 2, an x value that's close to my asymptote is -4. And you know what? Let's go ahead and do positive 4 as well. I could have found more, but remember, you can see we already have 2 here. So in section 1, I have a total of 3 points. In section 2, of a total of 4 points. These 2 here and these 2. Now, in order to find the y values, plug your x values into your equation. It's really as simple as that. That's why we have an equation. That's why equations exist. You can put in any x value that you want, and you get out a y value. I am going to say using a calculator can be helpful, because these often will end up being weird fractions because we are doing a rational. So I'm going to quickly type these into my calculator and see what I get out. So now that I have these, I can go ahead and plot them. So once again, I got this by plugging this x value into this equation, and I did use my calculator, and it gave me a y value. So I have one at -6, 9, -8, 4.3, so -8, 1, 2, 3, 4.3, -10 was 3.4. So this is enough information to see that I'm going to have my swoop that looks like this. You can see me kind of drawing it in, and that's because I know what a rational graph looks like. So just from these points, I know how it's going to connect. I'm going to have kind of that curve. That was not a great drawing. And as I get closer to this vertical asymptote, my line is going to get more vertical. As I get closer to this horizontal, it's going to become more horizontal. Each of your sections should have 2 arrows. What's going on is you keep going left, and then as you get closer and closer to your vertical asymptote. I can also plot the points over here. So -4 with -5. 1, 2, 3, 4. Oh no. Let me erase those little dots. I also had +4, 1.2. And once again, that's going to be enough for me to now see that my swoop's going to look like this. Same thing in this direction. As I get closer to my vertical asymptote, my line becomes more vertical. As I get closer to my horizontal asymptote going in this direction, it's going to become more flat. And we always try and curve it as best we can because we've seen rationals and we know they're kind of curvy. And there you have it. We have graphed a rational. So let's see if we can do it again. For this problem, I can quickly give you the information. Once again, if you want to see me do this slowly, you can go ahead and check out my other videos. I do this problem there, but I'll give you some hints. This becomes 0, 0 over -3, which becomes 0, 0. To get my horizontal asymptote, I'm going to compare those degrees. I'm in the eats DC area, so it's my leading coefficient over my leading coefficient. So y equals 3. I know I have to factor it now, so I factor this and I get 3x, x minus 4, x minus 3, x plus 1. Nothing cancels here. I do not have a common factor, so therefore I do not have a whole. That means both of these become my vertical asymptotes, which means that my vertical asymptotes are at x equals 3 and x equals -1. Reminder, sometimes you'll see me write those as the restriction. Because they are the restriction, this is really the location. So either or is really acceptable in this case. The domain is putting those restrictions in order. So we always start at -infinity. That's a terrible infinity. We start at -infinity. We work our way up to +infinity. I'm going to stop at -1. I'm going to go until 3. If these are vertical asymptotes, then these actually end up being the sections on your graph. So remember when I said we're going to split into sections. Writing this domain, You get it like that. And then last but not least, we have our x-intercepts. Those come from our numerator. So I'm going to get 0, 0, and 4, 0. So we're starting this from the beginning. That's the first part of what we need to do, is to find all of the key features. Now that we found the key features, we can plot them. So I am going to switch the slide. I'm going to write this all out again so that we have it so we can graph. So like we did with the first one, the very first thing I'm going to do is plot those points. Notice it's kind of cool here that my x-intercept and my y-intercept share a point. That always happens with the origin. So I only need to plot that once. I also need to plot 4. So those are the 2 points that I already know. I guess they don't need to be that big. We can go ahead and put in our asymptotes. So let's start with our horizontal asymptote. I have a horizontal one at 3. So I'm going to come up to 3 and then go across. I have 2 vertical ones, so I'm going to put both of these vertical ones in. I have one at -1. So same thing, I'm going to go across to x equals -1 and draw a vertical line. And same thing at 3. Now I need to kind of see my different sections and I need to find my x values. So because I have 2 vertical asymptotes, I see that I have a section here, a section here, and a section here. Remember, each time we have a vertical asymptote, it's going to split a new section. So I was going on until I hit this asymptote, and then I was going on until I hit this asymptote, and then I go on again. There's no more asymptotes, so this would be my last section. I'm going to call these S1, S2, and S3. So as a reminder, I'd say find at least 2 points in each, more if you have the time and you need them. So I'm going to split my table up into S1, S2, and S3 just so we can see visually. So in the S1, I'm looking for x values that go from -10 to -2. I always want to do one that's really close to the asymptote, so I'm going to do -2, and then I can do one that's further out, let's say -6. So -2 and -6 are ones that are in this first section. Now I want to look in between this asymptote and this asymptote. I want to look in between them. I already have 0, so let's just go ahead and do 1 and 2. And then last but not least, I have this last section. I already have 4, which is the closest one to this asymptote. And so let's do 6 and 8, just other ones out in that section. Once again, you can choose whichever ones you want, but you must at least choose some in each section. You need multiple points in each section to give a general idea of what it will look like. Same thing, now I'm going to plug this in, and it's going to give me a y value. Same thing, I'm going to use my calculator to help me out here. So 3x squared minus 12x divided by x squared minus 2x minus 2. Okay, so now that I have these points, I'm going to go ahead and plot them. Remember, I know on my edges, my far edges, I'm probably, especially since I do have a horizontal asymptote, I'm going to have some sort of sweep either at the top or at the bottom. In the inside, especially because my point's down here, either I'm going to have a parabola looking thing, some sort of U, or I'm going to have some sort of squiggle that looks almost like a cubic, or a tangent function, if you know what a tangent function looks like. So those are really kind of my options here. That's what I'm trying to see. As I go into -2, so -2, 7.2, that tells me I'm going to be at the top. -6 was +4. That gives me enough for me to go ahead and start sketching in this swoop. Once again, as we get towards the asymptotes, we kind of take the same shape as the asymptote. The vertical one makes my graph go straight up. The horizontal one makes my graph go flat. 2.25. 2 is 4. So here, especially since I cross the asymptote, this tells me I'm going to have one of those squiggles. It didn't come back down here. If this point had been down here, I would have seen that it looked more like a U, but it keeps going up, so I'm going to have one of those squiggles. Once again, as I get closer to the asymptotes, my graph started to look like the asymptote. As I get closer, it becomes vertical, straight up and straight down. I have my last one, so I can plot these points. 6, 1.7. 8 is 2.1, so we can see that it is starting to flatten out as we get towards that horizontal asymptote. Many people just want to stop here, but each section needs to have its 2 arrows. We know that this side should be a swoop, so as I go here, as I get closer to my vertical asymptote, I'm just going to drop down. And there you have it. We have graphed another rational function. So we've graphed 2 rational functions here. Find your information, your key features, plot those first. So intercepts, I have my y-intercept here. I went ahead and put my asymptotes in. If you had a hole, you would go ahead and put that in as well. You would just go ahead and draw an open circle. So let's just say, for the sake of this one, that we had a hole at -3, 5. We would actually come over to -3, +5, and draw an open circle, and that would be another point for us to connect. However, that was not the case here, so I don't want to leave that. That was just a what if. But so you can see what it would look like to draw a hole. Split your graph into the sections. Choose some x values in each of those sections. Find the y values, plot them, sketch. And that's graphing a rational function.